Welcome to our yearly edition of LCG Lightning Talks. My name is Amit Pundir. I'm a senior engineer in Linaro. These Lightning Talks are a series of short talks from LCG team members talking about the different work items that we have been working on since the last Connect. Unfortunately, Sumit and Sam could not be here this week, so it is me and Yonchin who will be covering for them as well. The first item on the list is development boards and AOSP. I'll be talking about the state of Linaro supported development boards in AOSP, and I'll also talk about the development boards that we support outside of AOSP codebase. Then Jonchin will give the updates on Android testing in Linaro. Coming to the first topic of the agenda, development boards and AOSP. Linaro has been a long-time advocate of AOSP development boards. We support a variety of member development boards in AOSP, and we do support AOSP on the devices which we do not support in AOSP currently. And we perform extensive testing coverage on all the devices which we support. And one of the many benefits of a well-maintained device in AOSP is you get to have a day zero boot of Android releases on those devices. I'll start with the new features that we have enabled recently. We have added support for 16K page size builds on our dev boards. These are page agnostic builds, so it works with both 4K and 16K page size kernels. We are talking about this particular enablement in details in a separate topic, in a separate session tomorrow. So if you are interested in this topic, please do join us in the same room tomorrow morning at 10:30, sorry. We have also enabled support for booting AOSP on our dev boards with GBL using U-boot. Again, this topic needs a bit more time for us to get into. So we have a separate session on this tomorrow morning again in the same room at 11:30. So please do join us. We have upgraded our devices to API level number 34. That means we have moved away from incompatible HIDL HALs to AIDL HALs, including the graphics allocator HAL, the keymint, keymaster HALs, and Bluetooth, to name a few. Other changes include we have downgraded our SM8X50 user debug build from ARMv9 ABI to ARMv8.2 because we recently ran into a build regression on SM8550 HDK, which is Snapdragon 8 Gen 2 device. Apparently, ARMv9 CPU ABI flag in AOSP can only be enabled for SoCs which enable SV2 support. And SM8550 HDK do not have SVE2 support enabled on that device. So we end up downgrading that particular build to ARMv8.2 instead of ARMv9. It took some time and multiple approaches and iterations, but the Wi-Fi Bluetooth support for Qualcomm SM8250 and newer SoCs finally landed in Linux kernel version 6.11. That has unblocked Wi-Fi and Bluetooth support on RB5 and SM8X devices. We have updated our vendor package to include newer set of Mesa binaries, to include a 16K runtime crash fix. We have also added support for generic thermal HAL and power AIDL HAL in vendor package support. It is based on upstream libpm project. It is implemented and maintained by Daniel Lescano of Linaro power management team. So other than these new features and fixes, there are routine development board maintenance tasks like usual weekly triaging of Android test results, smoke testing of upstream and relevant Android common kernel versions, and testing upstream Mesa and DRM hardware composer projects for any breakages. We removed the obsolete SM8450 user debug build target from AOSP because SM8X50 now supports booting 8450 as well, and it boots to UI. Speaking of SM8X50 device support, this particular build target in AOSP now supports booting AOSP on pretty much all the Snapdragon 8 Gen dev boards which are currently supported upstream. So that includes all the 8450 dev boards, all 8550 dev boards, and 8650 dev boards. We are still blocked on some issues though. For example, UFS on 8550 HDK is still buggy and not usable. So we continue booting from MMC SD card on that device. Snapdragon 8 Gen binaries, firmware binaries are still not publicly available. So our stock builds, our public builds boot with software rendering support, and there is no audio and Wi-Fi Bluetooth enabled. But if you have the device, you already have the firmware binaries installed on that device, so you don't need to worry about that. Now, other than the dev boards that we support in AOSP, we do support booting AOSP on E85096 board. Sam has worked on enabling U-boot support on E85096, and that has unblocked us by enabling GBL support on that device as well. We have enabled E85096 in LKFT, and we have already caught a few upstream Linux bugs on that. From AOSP point of view, since we are blocked on DRM KMS driver support on E85096, we have enabled AOSP booting on E85096 with virtual KMS driver. It will help us run CTS and VTS test runs, Android test runs on that board. And now the work in progress items, or the next items in our to-do list, includes upgrading our devices to newer API level 35 and beyond. We want to simplify booting from external external storage devices. So we want to switch to using partition UUID boot arg to select the boot device. We have enabled GBL on RB3, RB5, and pretty much all of our development boards. And we are close to enable and make use of GBL to boot Android in the testing lab. We are also exploring usage of VKMS display in Android. As I mentioned earlier, in the context of E85096, VKMS can be used to unlock Android development and testing on the devices with limited display or GPU capabilities. With the AOSP main moving to read-only mode, we have moved our day-to-day development to dev boards for Android project repo, while we wait for respective patches to land in upstream AOSP main. Documentation and how-to guides are publicly available on dev boards for Android project. So if you are interested in making use of that project, you have all the resources available there. With that, I'll hand over the control to Yonchin, who will give the Android testing updates.
Thanks, Amit. Good afternoon, everyone. I'm Yongqin Liu from the Linaro Consumer Group. Here I will give a short update on the Android test status at the Linaro side. First, for those who didn't know LKFT before, LKFT is short for the Linux kernel functional test. Is a framework and a collection of software tools and hardware devices. LKFT for Android includes the running relevant CTS VTS subsets on Linaro managed dev boards. Also includes triage the results, report and fix the bugs found. The tests are run on 5 devices with 6 user space 15 kernels, resulting in a total of 75 combinations on a daily basis. The devices include the SM8550, RB5, RB3, and also the high key 960. Here, the high key 960 are legacy devices like devboard, which are only maintained with the best effort for now. The user space covers the AOSP main, Android 15, 14, 13, 12, 11. The kernels covers all the active Android common kernel branches like the Android mainline, Android 11.5.4, Android 12.5.4, and to the Android 16.6.12. Awesome. We have run 1.5 billion tests since last year, and 4.9 billion tests since started. There are some new configurations newly added since last year, including the setup for the SM8550. Is the SM8550 configurations are set up based on the SD card boot. It covers the user space is the AOSP main, and the kernel are the Android mainline and Android 16.6.12. Covers both the 6K, both the 4K page and the 16K page builds. There is also one private configuration setup because of the redistribution of firmware files. About the 60K build configuration setup, it mainly on the Android mainline kernel branch. There are two VTS modules run there. There's the VTS 60K page size test and the ERF alignment test modules. The full CTS VTS and the pre-semi test are added with the Android mainline branch. This time, and but the full CTS test for the old Android versions like the Android 11, Android 12 stopped now. For the we also added test for the Android 15 user space with various kernels. There are more SD card boot based setup enabled. The JBL setup will be supported soon. We also enabled the KUnit test. About the introduction, here are two links on the upstream side and on the Android Linux side. Please check please check them for the details. The KUnit test is mainly enabled with the AOSP main user space with the Android mainline and the Android 16, 6.12, Android 15, 6.6 kernels. We use the Google Trade Federation pre-built repository to run the KUnit test and the parse result. Besides that, there is one test.zip file that includes all the test unit KUnit kernel module files, which is normally generated with the JKI kernel build. Here, for the convenience, we make it published with DB845C build. Here is a list of what we are doing with the test suite tools. Currently, we use the test suite big command to build the AOSP user space images and the CTS VTS packages, but there is no test run on them. Next, we we plan to use the task suite plan command to submit the build and test together. That way, the user space images could be generated, and then test will run against them. So for the task suite introductions, please see the following two links for the details. Yeah, that's all. Any questions?